Hello everybody, we're getting right into it today. It's number 69, PogChamp. So yeah, let's make our little Discord announcement. If you don't know, just went live. If you don't know, there's a Discord. You could join it. There's a whole bunch of stuff. You can talk about video games or music or philosophy or post coding resources, talk about anything and off topic, and talk about programming in general. And yeah, come to announcements for notifications every time I go live. And you can also ask to be pinged, but to ask to be in this notice group, and I'll put you in it. It's been a while since I've done this. Hopefully you can tell. And hopefully you'll forgive me. I am in the VC right now. You can join the Discord and pop in the VC. And we're going to have a fun little stream here, I think. We'll pop back into Emacs. I have a different setup today. I got one screen. So I may be behind on chat a little, but I'm gonna do my best to check it. Alrighty. I wonder if I could get it up on my phone. Let me see if I can do that. Hey, look. Twitch sabotaged me in the best way. I can see the chat here. Perfect. Wonderful, wonderful, wonderful. I made the announcement in the Discord. I did the YouTube thing, so we are live and we are ready to go. And we're in Emacs, so we're just gonna go to our Streama 2023 intercept rewrite. If you don't know, the compiler is being rewritten in C++ because C is cumbersome when you try and do complex things. Finalte says first. What's up, Finalte? How's it going? I'm a magician. So we are going to check out we're just going to continue what I was working on. I've, again, different setup today, so no tree sitter. It's going to complain every time, but we also have a newer version of ClangD that supports inlay hints, so that's cool. How fun is that? Eternal's back.
Hello.
Verlio H says second. What's up, Verlio H?
Which, here we go.
Am I not streaming in the Discord? Did I screw that up? I did screw that up. Hold on.
Sorry, what'd you say?
I'm on it.
There we go.
Essenin says, oh my god, hello, it's been a long time. Thank you, I appreciate it. It has been a long time. Thank you for the hellos. Hello, everybody. Thank you for tuning in. So, yeah. We're gonna do some crazy stuff. Mousix says, hello and goodbye. It's late here. Good night, Mousix. Get some sleep. Treat yourself. You deserve it.
I'm quite sure where you currently are in terms of what you're talking about, but I have a list of things I would like to go over.
We're right at the beginning, so that's perfect. What's your list?
Okay. There's a few C++ topics on here and also a few general things.
Okay. What do you want to start with?
Before that, would you like to give an update on the compiler? Have you already done that, or?
I haven't done that. Let's do an update on the compiler. I talked about like what we're doing, but not how it works. So you just use CMake like normal and CMake build. It'll do a bunch of stuff. Don't worry about it. And what you'll see I'm doing here is using the cursed LLVM backend that I've never been able to use before. And I'm running it through Clang, and it's actually going pretty well.
That is quite the pipeline.
It is quite the pipeline.
Do you still have and, or do you just like using semicolons?
Semicolon is the and of new shell.
Okay, that is weird, but alright.
You can make it look like it's because the scripting language is the same as the shell language. So
is there a way to do
semicolons
what
and
semicolon usually means?
What does I don't know what that usually means.
Usually what it does as opposed to and is it executes the command irrespective of whether the previous one failed.
So that is I think you have to handle that in a different way. I can't remember. Like you pipe it into a certain thing and discard it, or I can't remember. I don't often do that, but there is a way to do it. I've had to struggle with that in a script once. But yeah, you can see even like string literals is working. And let me load into my Emacs.
Maybe take a look at that file, yeah.
Int mode. I've been doing this so much. Here, I'm going to make this a bit bigger for you guys. There we go. Lorem ipsum dolor citamet contactor.
Presume that name reads FN Alt E is asking, is that guy Danish? No, I don't think Len's Danish.
Ha! Yeah, they were definitely talking about me. I sound Danish for sure. He's from some part of the world. It's very fantastic over there, I'm sure. As it's fantastic here. But yeah, this is the file. As you can see, we link with the C library by default because we're using Clang to compile. And we basically have puts from the C library, and we just pass it a byte pointer, which is like a C string, I guess, because in intercept strings are arrays, but this is how we interact with C. And then we basically just get the 0th address of this array, put that to string, and here's the crazy part, new intercept. You don't need parentheses, and actually shouldn't use them if you don't want, for function calls. So puts here is a function call with an argument string. How about that?
Okay, to follow up on the question, they're saying, I'm talking about the guy from Discord, his name starts with an ash. Yes, no, just because my Discord name starts with a letter that just happens to be part of the Danish alphabet does not mean that I'm Danish. Because that letter was also used in English up to is hard to say, but I think it fell out of use in Middle English, approximately. Well, it was still used as a ligature, but as a letter, I think it fell out of use in even late Old English, even. But it used to be a proper letter in English, so.
Get wrecked, kid. Strings are null terminated even though they are arrays. Yes. This syntax is short for a byte array that is this many bytes long with a null thing on the end. Which we can see if we print out the AST. Oh, I'm going all over the place. Hold on.
Oh yeah, you can see it in the. I mean, you'd have to count the characters to be able to tell. Don't think.
No, I think the array will. Yeah.
We'll see.
The type should. I've made mistakes.
Perhaps try not to compile our AST printout.
That may be a good idea.
Yes.
So as you can see,
it's not currently not printing the value. We need to fix that. I need to fix that.
Yeah,
we can fix that later. We'll see.
Yeah, that's fine. We can fix that quickly. But yeah, so this we could I forgot what it is. Count words. 39 characters. Look at that. Thanks, Emacs. We can look at it larger here.
You can also take a look at the IR, and in the IR, the null terminator will be there explicitly. There.
There it is.
I'm using LVM style escapes with backslash and then 2 hex characters.
That's fine. 2 nibbles. I like calling hex characters nibbles. I think it's more accurate. Few nibbles. Yeah, as you can see, we're calling puts. That's what this thing is. And then we return 0 because puts returns void, and we can't return void from a program. It'd be a little odd.
Puts returns the number of characters printed, but
yeah, we don't. I guess we do have C interop. We could just do int. But
yeah,
it'd be fine.
You can do I32 because it returns, I believe, an int in C, which is an I32 and intercept.
If we want to make these tests just for x86-64, yeah.
Yeah, that's also a thing. We don't have FFI types here or anything like that.
We will.
I mean, I think that we have them internally. They're just not exposed currently.
Yeah, we got to figure out a way to do that. Honestly, I'm thinking about just like a specific, it's kind of cursed, but like, could C be a type or a keyword? Like, what if we just did C int?
C underscore int or underscore C underscore int, and then regex, and then define type aliases for them in some. In like this could be a built-in keyword and define an
That's
alias
right.
for it in some standard library module or whatever.
Yeah.
Or the other way around, like underscore C and would be like a built-in type.
Yeah,
and
and
then
yeah. And then we'd name it like whatever we want to do. If we wanted to name it C int or int,
something like that. Like the standard library could expose that as C underscore int or whatever. That would probably make sense in some FFI module. That way, it wouldn't be in scope everywhere. Just if you wanted.
that's a great idea. Okay, but yeah, it's working. Through.
How Pyro Death Adder is saying no parentheses Python 2 vibes. When
Oh
Python
God.
2 is the last thing I would ever think of. It's like literally any functional language that isn't the Lisp more or less uses the syntax. Like, and also Perl. It makes me think of Perl.
That's right. Yeah. It does make me think of Lisp. Because you just put parens about that's Lisp.
Mm.
And how do we group things when we like? Let's say we wanted to like pass the return result of a function.
Mm-hmm.
Can we do that? We can't do that. Can we do that?
You can do that. You should be able to do that. If not, then that's very easy to add.
And if we wanted to like call string func, we do it like this, right?
I think so. I forgot whether invoke is right associative or left associative, because I'm using a similar syntax in my language, but in my language there are reasons for why it has to be left associative. I forgot what it is in this language.
Looks like it worked.
It would be easy to see if you showed the AST instead of the IR, just saying.
That's right above it.
Call expression, it calls... Oh yeah, well, you put it in parentheses, obviously, that's going to work. Yeah.
Fantastic. So yeah, you can still pass like functions as well to functions. It's kind of like if it expects a thing, it'll take the thing, but don't use parentheses, then it'll call it. So ironically, parens still call functions, just only one nested level deep and in a different place. I like the syntax. It makes things look very clean. And it's unique. I like it. What was that one? I'm going to keep that one up. Okay. I tried to execute the AST again, I think.
Yeah, that's not going to work.
No, I didn't. What did I do?
I don't know what you did. You emitted LVMI, I think.
Oh, I did the old way.
Oh,
it's now
no
dash F.
LVM. It's probably yeah. There we go.
Hey. But yeah.
People are asking about whether this is going to be memory safe. Well, more so than C, sure. Hopefully, at some point. Because being less memory safe than C would definitely be quite the accomplishment, probably. But it's not like a main focus of the language, like in Rust or anything like that.
That's a great way to put it. Mr. Mugame is laughing at my semicolons. Yeah, he's been here for a while.
Semicolons make things easier to pass, yes.
Sam CPL asked, lol, what language is this? This is Intercept, a language we made up over a year, I guess. And I guess today I'm going to work on, Eternal's going to talk about C++ stuff for slightly. I was just going to get the GNU assembly started. We're going to just go IR to assembly right away. That way when we finally build the MIR, we can just like change this code a little bit, because IR and MIR are very similar. And we'll just pop it over.
Any last things you want to talk about? Or?
Nope.
Sure. So a few things. The one thing that I've noticed a few times is let's put it this way, you might want to use views a bit more, especially views enumerate and views transform. If you look in the code base somewhere for views enumerate, so VWS : enumerate.
I can't. I don't have grep yet. You can't.
How do you not have?
It
Sorry,
doesn't come
but
with anything. I just got a new install of Windows. You gotta
okay,
work
but
with me.
like, okay, well, you could literally write grep probably in. Okay, there we go. Emacs has grep apparently.
I don't think it does. Let me try.
Okay,
It doesn't.
Jesus Christ. Oh
We
my
don't
God, I
have it.
can find one for you, then I can run grep.
Fantastic.
Good God. Never
Have our grep.
would I thought I'd ever hear the sentence, I don't have grep. That is really cursed. Um,
Yeah, I
let's
don't have
see.
it.
Right. For instance, in ir.cc on line 28, lcc ir.cc on line 28. There's
Hey,
an
I was
example
very
of that.
close to there.
Yeah, so basically, perhaps so we don't, there we go. If we look on line 30, type params is a range, and I'm calling views enumerate on that. And that's like enumerate in Python, for instance. And what it does is it returns both the element and the index. So if you ever need to iterate over a range and you also need the index, use that.
Is this like a spread?
This is destructuring.
Destructuring. That's what this one
It
is.
returns a pair, and this, I think it returns a pair at least. The official term for this in C++ is structured binding, but it's basically destructuring. And in this case, it's doing it by value, simply because, well, param is a pointer, I is an integer, so there's no reason to do it by reference. But if you want to bind by reference, you can do auto ampersand or const auto ampersand.
Oh, naturally, yeah.
Bind by reference instead of by value. But in this case, it doesn't matter because it's an integer in the pointer. But yeah, if you that way you don't need an extra integer variable or anything like that.
That makes sense. Did I do that somewhere? Did you fix it here?
I'm not sure. Whenever I see it, I fix it.
Okay.
Put it that way.
I remember for sure putting like int I equals 0 for blah blah blah.
Where I did fix it, yes.
Nice. Okay.
That's one. The other one is views transform. Let me see if I can find that one anywhere. Oh, there's a bunch in the same file on line 132. That's also a very nice example of how to use form or join. I forgot about that. So this is a complicated one. I need to explain this one a bit. Most of this stuff is fairly simple. Just some formatting going on. C red is a color that's depending on some boolean, either gives you the string that sets the color to red, or an empty string. And then there's that line 134. That one is the interesting one. So first of all, we have, if we read this inside out, we have views transform. Transform is what C++ calls map. This is just map in Lisp. So we're taking params and we're mapping the toString function over it. And that's a lambda declared up here. That basically converts all of these parameter types to strings. So now we have a range of strings. And then format join prints those separated by a separator. So that way you don't have to do the weird thing where you check, am I on the first element or am I on the last element? Do I insert a comma here? Do I delete it? And no, just format join, range separator, done.
Very nice. So views is kind of like functional stuff.
Yes, basically there's a bunch of them. There's filter, there's fold, and a bunch of other ones.
Oh, they have folding. Okay. I'm interested now.
It's not views fold, it's ranges fold. There's fold left, fold right.
Awesome.
I mean, standard accumulate is basically just fold. It is just fold.
Yeah,
it's just called
it is.
So yeah, that's that. And I have a good example of one we can try out. There is in the I just wrote down in the type bits case in the implementation of type bits, which is probably in here actually.
Yeah, it's still here.
There we go. Go to the case for structs. I just wrote down refactor this as an example.
Ooh. So
So what do we do here? Let me quickly see what we're doing here. We're looping over everything. I don't think we need to enumerate this one. I don't think we need
we
indices here.
don't.
So let me see what we need to do here. Let's take a look at this. Let's
So
go back a bit.
we just need to. Oh, I know what we need to do.
So we're looping over it. We're mapping each member to bits, and then we're folding that. So we can try that out.
We could fold left, yeah, with plus.
We can try. First of all, what we can do is we can do the mapping to bits. I'd start with that, perhaps.
Do the mapping to bits. What does that mean?
So if we're calling sum plus equals m bits for each member.
Yes.
So we can just take the members range and do a transform on them.
Like, are you saying like this?
Yeah.
Okay, just making sure. So we want to transform.
That we can pass in. So the range is first, and then
We'd have to
lambda.
do
There's several
add.
things we can do. Before you write anything, we could pass in a lambda or something, but in this case we don't even have to. We can just we're just calling a member function on it, so we can just pass in the member function, which in this case is type : bits. But we need to, that would be calling the member function. We need to get a reference to the member function.
That's right. Do we have to do this?
For a member function, you have to write ampersand type : name.
Like literally that?
Well, the name of the type is the type is
I
called
see.
type. This is the worst thing.
I see. Okay.
Yeah, that's the problem, because normally for a function reference you don't need the ampersand. For a member function you do.
Oh, that's terrible.
So that's that, and now we can remove the call to bits in the loop, for instance.
Okay. So we don't need bits because now, okay.
Now we can just grab that, and we can probably just fold this.
Do we even, so we just, so this will return a list of stuff.
Conceptually return a range, as it's called in C++.
Okay,
yes.
a range, yeah. I'm going Lisp fully. So then what we want to do is fold left because this is addition. We could fold right too because it's addition. We want to start with 0.
I haven't done this in a while, but you should be able, for instance, to pass in a lambda, but I think you can even pass in standard plus and it might work. It might not, because this is like a weird thing. But there is a function object called standard : plus that you might be able to pass in that just adds.
That would be sweet.
I believe this is a type, so you have to instantiate it. You have to do this and also like parentheses.
Yeah. And then
I think that. Do you need an initial value for this one? I haven't used this.
Oh yeah, you do. For fold left, you do.
Typically, you do. Yes.
What's it mad about? Ignoring return value of function. Fold left.
Okay, so yeah, now the sum is that.
Yeah.
So that should work, I think.
Let me help out viewers in case anyone's confused, because we just did a lot of stuff that requires a lot of high-level knowledge. So I'm going to use Lisp because it's what I know. So imagine that this is a list. So like if there's nothing in the list, it would look like this. And if there's something in the list, like let's say a number, there's that. And if there's two things in the list, it's like that. Fantastic. Now that we've got that out of the way, the first thing of the list could be like a function call, like foldle. And then this is foldle on, basically map of members to a getBits function, right? And then we're going to start with 0, and we're going to apply plus. So this is the Lisp of it. And basically, map goes through each element of the list and applies a function, as we went through, I think, pretty well. So, for example, if the members list is like, let's just say we map it, and the bits of the members list is like 32, 64, 32, 32, 16 or something. Then what foldle will do is something, it's kind of confusing, but it'll basically fold this list into a single value leftwards. So it'll combine the initial value and the first element as two arguments to this function plus. So if we do plus, and then it would do 0 and 32, and then it would keep building this accumulator, because that would equal 32, and then it would do, okay, plus our initial value, which is now 32, to 64, and then that equals 96, and then dot dot dot. It would end up adding all of them.
166, I believe.
176. You were very close.
Always 10 off.
So it would get 176 bits, and then that 176 value, this initial value, will have been folded on this. This whole list will have been folded leftwards into this initial value. It's very confusing, but if you know functional stuff, you'll get it. Mr. Mookum.
Yeah, like who isn't a senior Haskell dev.
Oh, that's amazing. Yeah, I mean, who here isn't?
I thought I'd get you to use ranges a bit more if I explained them to you in terms of Lisp functions. There you go.
That worked much better, yeah. I understand what this is doing now. Views is going to be insanely helpful.
Yeah, and one more thing that you can do with views, and this is a thing that's with views transform especially, a bunch of these other algorithms take what is called a projection. So if you ever see on CPP reference, well, if there's a parameter that's called projection or something like that, that will basically apply a map to it. That's what that means. And views transform does just that. And what you can do in these cases, you can pass in anything that is callable and it will call it. And specifically anything that can be passed to standard invoke. That's like the underlying mechanism for all of that. And that includes a lambda, a free function, a member function, or also just a pointer to a member. So for instance, what you could do is, if I'm not sure if we have, if we look at the type struct real quick, or class, it should be in the same header.
The LCC type, not intercept.
Yeah. Does this have too fast? You're going too fast. You already missed it, I think.
It's not in here.
Is it? It's okay. It's probably in the type header, not in ir.hh. It's in ir type probably.
Fantastic. That makes sense.
Yeah. So this thing, it's the first thing, I think. Yeah. Okay. In this case, there is no public member, but what you could do instead of passing in a function, you could also do ampersand type : kind. And if you pass in a member name like that, it will it's the same effect as mapping it to that member effectively.
Wait, what?
Okay, see how we're on line 27, we have this member kind.
Yeah.
If we go back to the CC file, if instead of ampersand type : bits, you wrote ampersand type : kind, that would also work, even though it's not a member function. It's a pointer to member. This is a bit of a complicated construct internally. The only thing you have to know about this is if you write class name : the name of a non-static member, then you can pass that to something like transform, and it will convert all the elements to that member.
So it would try to convert it to this type?
It would access the kind member.
I see now. Okay.
So this is a bit of a complex operation, even in the semantics of the language too. I'm not going to go into any more details. You don't need to know anything more about this. The only thing, because again, standard invoke handles that internally. The only thing you need to know is the syntax for creating such a pointer to member, which is ampersand class name : and then the name of the member.
That makes a lot of sense. It's kind of weird. I've never seen it before, but yeah, this makes so much sense.
It's used in like situations like these if you're passing something to a standard algorithm.
Yeah.
So that's one thing.
Awesome. We did it.
And the only other thing really is I wanted to talk about CRTP a bit, because that has come up with the IR printer. We can take a look at that real quick, because we now have a base class IR printer in, I think it's in utils. but not in utils CC. It's in a header in the utils directory, I believe.
Nice.
IR
Yeah.
printer, there we go. So what we see here is
Nice.
an example of what's called CRTP, and in order to understand that, we should probably take a look at and implement a derived class of this. You would find one, for instance, in ir.cc, funnily enough. At the bottom, there should be one, but it's pretty long. It's like all of this, I believe. Yeah.
Yeah, so we'll just take a look at this stuff. You know,
we
it's
need
good.
to take a look at like the start of the class declaration.
Okay. Oh, it's very mad.
It's a bit further up. There we go. So see how LCC IR printer inherits from IR printer templated over itself. That's a bit of a weird one. Now that we've seen how this is used, let's go back here. Now we can take a look at this. This pattern is called CRTP. It stands for Curiously Recurring Template Pattern. And it's basically a way to do polymorphism without virtual functions. It's also called static polymorphism. And what we see is, if we go, for instance, to the, let's go to the print block function. It's further up here. So what you'll see is this does some common thing. We print the block, blah, blah, and then on line 60, we call print inst. The thing is, this class doesn't define print inst. It relies on the derived class to implement that.
Without a virtual function.
It is like a virtual function, but it isn't a virtual function.
That's awesome.
And the way this works is, if you just wrote print inst without this this thing that I put here, it wouldn't compile, because the compiler would go and say, I don't see a print inst here. That doesn't exist. And of course it doesn't exist, because it doesn't exist until this thing is instantiated. But when it passes this declaration, it doesn't see a print inst, so it would complain. The way we stop it to complain is we tell it, okay, you should look up this function later when it's instantiated. And the way we can do this is by writing, in this case, using this helper function that I wrote that casts the this pointer to a pointer to derived. And derived is a template argument, so this won't be known until it's instantiated. So the compiler can't tell whether print inst exists or not until it's instantiated. So it will wait to look that member up until it's instantiated. And then when we instantiate it, it will be there, because the derived class does define it. And that is why you need to pass in the derived class as a template argument, so you can cast this to whatever the derived type is, and then call a member on that. And you'll see this function does implement, this class does implement print inst. But print block is handled just by the pattern. So this is a way you can do polymorphism at compile time without virtual functions.
That's very cool. How did you do it? You just pass in CRTP. You just pass in a recursive.
Yeah, the key 2 points of this is the derived class
and this
inherits from the base, and the template argument to the base is the derived class itself, and then you just cast this to the derived class.
That's so cool. Is my microwave going mad here, or where is that beeping? Oh, hold on.
I'm not hearing any beeping.
And I'm back.
Oh, welcome back.
I fixed the beeping.
Yourself in Discord, so I wasn't sure whether you were gone.
I just went for it. I was still in the room. I just didn't have my
see.
headphones on. I did it.
So
Okay.
yeah, that's CRTP. Just wanted to mention that because also this base IR printer class is also used by the LLVM IR printer. Perhaps someone surprisingly. And the AST printer operates on the same principle because Lai, I think, also uses that one.
Nice, nice. That's right. There's also an AST printer in the same way.
And it's the exact same thing. Just a bit more temple parameters because the ASTs are different.
Yeah. Cool. Very cool.
And this will get easier once we have more support for C++23 with deducing this, but I'm not going to go into that here. But that is a way to simplify CRTP.
You ready?
For what?
The first instruction has been implemented.
Okay, so that was the C++ stuff. I actually do have a few more things I want to mention.
Perfect.
I would argue it would make things easier if we could all agree to use Clang format, because currently, whenever I have to edit code that we're working on and I reformat, the entire file is just changed. And so I have to remember to format it locally, and then even then, it doesn't always work well. And I will say, I don't know whatever formatting Emacs is using, but it ends up looking rather scuffed at times, where you have the case and the switch on the same indentation level, and that looks really scuffed as soon as you have a case that also has a block, because then you have two closing braces on the same line at the end.
Let me see if there's if I can change that, just like right now. I don't know if it's easy. If it's easy, I'll do it right now.
I mean, what you can do is, and I've done that before in Emacs, I don't think it was that hard, is literally just make a new key binding and just run Clang format manually.
Yeah, that's probably the way to go. But
I think
I'll have to set up
that
Clang format.
Oh yeah, you need to have Clang format installed for that. That makes sense.
Yeah, I'll have to do that. That's a good idea though.
Because we do have a Clang format file in the repository, I believe.
Nice. Yeah. Then I could just start using that. That's a good idea. So
I remember there's even a package, an Emacs package that's called Clang format.
That's probably like on save. That's probably, is it a minor mode?
I don't know what it is. I just have in my .emacs use package Clang format. That's all I can tell you.
That's fair. So one thing we're gonna run into with this is we're gonna have to lower the IR.
Yeah, that is like that will take a while.
Yeah, we're gonna have to do that though. If we
want
want
What kind of instructions are you emitting here, by the way?
What do you mean? We're doing assembly.
Well, assembly from IR isn't gonna go well, I think.
It's why not?
Well, because it's missing instruction selection and register allocation mainly.
Register allocation is the big one, but
instruction selection is also a big one.
Well, it is, but it isn't. We went IR to assembly for a long time. I'm not saying we're going to here. I'm just saying that since instruction selection is going to take ages, why not get a backend going?
That doesn't work properly. I just don't quite see the point of it.
Why not?
You have a backend that doesn't work correctly or well in the general case.
Just to start working on emitting code.
Now if we're going to replace it later eventually.
So what should we work on? Because I don't know how to do instruction selection in C++, how I want to do it.
That's also another thing I wanted to talk about.
You should do that.
Yes, I'm going to do that. But like, there's two more small points before that. One is, prefer not to use break if you have a return before that, or like an assert false or an unreachable, because the break doesn't do anything in that case.
I'm okay with that. It's consistent.
And the thing is, my ID C line gets pretty upset if you do that, and and suddenly it marks 10 errors in this file, and the errors are just unreachable code because of a break that will never be executed. So you
It's
may have
just
seen it in
consistent styling.
some of the commits I've like consistently started removing breaks in the middle of nowhere.
Because your IDE is scuffed.
Yeah, because it just screams at me and tells me this code is why is this here? This is never going to be executed.
Right, like a semicolon.
What do you mean a semicolon?
It's never going to be executed. Why is it there? Just saying. Your IDE is freaking out. Comments are never executed. It should just be okay with it.
If there's a break after a return, that's unreachable code.
Yeah, that's not an error.
Yeah, but it's just not necessary either, and
that doesn't matter.
In cluttering the code with random unnecessary lines that don't do anything.
It's just consistent because you write a million cases at the beginning. You populate the switch and you do like select all the lines, and then you just write like case. You know, it's already populated, so you just write.
Yeah, and
break.
then the first thing you do when you actually implement the case is you remove the break when you're done with it. You just have to remember to do that.
I'm not great at remembering.
I see how it is, so
we'll try.
But that's one thing, and the last thing is there's two topics I guess that are a bit longer. One is what to do about testing, and I have an idea for that. And one is what to do about instruction selection. Which one do you want to talk about first?
Let's do instruction selection so we can start on something.
Okay. Well, there is a few possible approaches. We could do something similar to there's like three main types of approaches, if you can call it that I can think of. Well, four, but the last one isn't really an option. One is what we've done before, basically, is where we just have some file format that we pass, and then we do everything based on that. And I think the main question is how do we encode the like patterns and everything? That's the main thing, I guess. So one is what we did before. The problem with that is you have that separate pass step. You somehow need to bundle the file, which will get easy with embed whenever that drops, but that's going to take a bit still. It also has some overhead because it's dynamic, so we can't do any optimizations based on that. That's, I think, the least of our problems, but still. And it just requires us to write a parser and all of those data structures, and that's just a lot of extra work. Like, you basically have to maintain a separate file format for that. That's one option. The other option is something similar to that, but basically generate code instead. That would be like table gen, something like LVM table gen, where you have some DSL that actually generates code that is then executed rather than a DSL that is just parsed and then. It's basically a variant of one. These are very similar, basically. The third one, I'm going to get that one out of the way early because it's nonsense, I would argue, is to implement every last pattern manually. Like in code, just regular code, but that's horrid. We've done part of that before and it sucks.
Yeah.
And the fourth option I can think of is just use template metaprogramming. That
one sounds cool.
This one do basically what I did for my command line options library, but for instruction selection. So if we look at the pros and cons of this, I don't think I need to discuss three.
Yeah.
1 and 2 sound like a lot of work to maintain the format, and they would be a bit slower because, well, it needs to load the format and so on, and it can't optimize it on compile time. Whereas with 4, we're basically just generating code using templates. The only problem is the templates are going to be a bit large, and I don't mean a lot of code, but the types are going to have a lot of parameters. So if you get an error message, it's going to fill your entire screen with just one template type.
Yeah.
That's the only problem. It gets the error messages will get a bit long. Like if you can take a look at this, if you go to the to lcc.cc, like the driver. If you want to see what this is,
LCC
what we're talking about.
Driver.
Go to the driver and then just go into the main function and like purposefully misspell the name of an option somewhere.
Yeah, we've done this before.
So yeah, like put some random garbage in there and then compile it, and you'll see.
Well,
what
I
I
will
mean.
try.
Okay, now zoom out a bit.
Well, it's right here.
Yeah. So can you maybe full screen this so we can?
Not well.
Not well. Good God. But yeah, that is the command line. That's already bad enough. But if we go down a bit,
What are we looking
this
for?
here is a type. Like the entire thing here, this blob of text here, that is one type. That is the command line options type.
Yeah, that makes
So if
sense.
you get an error message, it's basically going to look a bit like that, with shorter strings, but still.
And then stuff, ideally something here.
Yeah, there should be a static assert. There will be tons of static asserts, obviously.
Perfect. But yeah.
So yeah, that's
So,
like the main concern, I think. And like the template metaprogramming, you need to know how to do this stuff. That's a bit involved, but it's not that bad, I think. There's just a few things you need to be aware of. And yeah, that is basically it. I can show like hold on, where is my thing? I have a little proof of concept that isn't really implemented or anything, but just what this might look like. I can show that real quick.
nice.
If you'd like, I can perhaps share my screen because then it's easier.
Yeah.
I can scroll down. Where did I put this? I think it's here. Is it here? It is here. It seems like it. Oh, I have too many things open as always. Get rid of all of this. Is this it? Yes, I believe this is it. Okay. So, where do I do this? Here.
Emacs is frozen.
Is this the right one? This looks like it is my IDE. Where is anything? Okay, hold on. I need to stop watching you. Yes, I think you're seeing the right thing. Okay.
It looks right.
And people on stream see that?
It's
currently there. Oh yeah, you're pulling it up now. I
yeah.
see. Okay. So basically, this is gonna get a bit more complex, so don't worry about it. So for now, a single pattern could be represented in the most.
Uh-oh. Oh, the ins and the outs.
That's out of business. I'm going to switch to the browser because my Discord can't handle this. I'm gonna be right.
Folks. That's so good. DSL, digital subscriber line, lol. No, it's a domain-specific language. Emacs is frozen, so let's solve that scenario right now, huh? It's one of these million ClangDs frozen.
Classic problem. I've had that before where it just doesn't want to do that.
It's that one.
If I have Discord open, it doesn't happen in the browser. How many ClangD processors does one man need? Good God. Okay. Are you seeing this now, by the way?
Not yet. One sec. Okay. Just slightly dying inside. I did it. And they can see. We're good.
I don't think the people on stream can see that.
They can. I promise. Yes.
Oh, it's just a bit behind. Yeah. There we go. Now, okay. So what was I talking about? Ignore this for now. This is like Basically, we have inputs, outputs. The inputs are an instruction, a less than instruction that takes and register an immediate, a conditional branch that takes. In this case, this is my syntax for denoting like the same.
The first instruction of the input pattern.
As well as two blocks, and then it outputs this stuff.
So, and the numbers there, the O, those are operand numbers?
Yeah, they refer to operands of these instructions here because you can't really name. You could name them if you wrote something like this. You'd have to write it like this, and then you could do something like foo down here if you want. I'm not sure that's more.
I don't think that's worth it.
Yeah, I don't
There's
think
gonna
so
be
either.
so
So I
many
just
of
went with
these.
this one. That's something you can do. And val is just a literal value.
Okay, nice. So
Oh, and then in a similar vein, you could define what is this? This is less than the exact same thing, but for 2 registers.
nice. Yes. I
So
have
here we have
a.
the exact same thing, but this time it's greater than instead of less than.
So where is like can I look at the definition of O or something? Like how is code
Well, this
being
isn't really
run?
implemented; it's just a stub for now.
Okay, how would where would you could you write just like a regular function, like a C++
What do you mean a regular
function?
function?
See, so like imagine you wanted to get the size of a type of the third operand. Could you obviously operands don't have types, so that's a little rough. But could you get the that data in like C++ and then have it be part of the template? We wouldn't have to like special case that. I just don't know if it's easy to like add new code to run, if that makes sense. Because I remember in our iCell, we had like 3 things we wanted to add. It just became difficult.
Very simple examples. I have a few more things that I want to show you. Maybe that will
That'll help. Yeah.
help. So this is like the most basic. We can already see this is a bit horrible because this is the same as this. The only difference between these two are these 2 operands here. And these 2 are the exact same 2 as these 2, except we have less than and greater than equal, and here we have greater than or equal, and here less than equal. So this is a bit of greater than and less than or equal. So this is a bit verbose. But this thing is, these are types, so we can work with that. We can grab this and factor this out. And the only thing we have to keep in mind is for greater than, we have a jump type of less than or equal, and for less than, we have a jump type of greater than or equal here. So this needs to be a parameter. We can make this a template.
We template the templates. Goddamn.
Yeah, and yeah, this is in this case, this is
conditional compare. Yeah.
Using a template and using declaration. Yes. Now we can abbreviate this by factoring out this common clause and just passing in the jump type. Now we don't have to write this every time, but we can use this instead.
Can we like?
It's already shorter. Yeah.
Can we map on a list of patterns, or a list of like less than, greater? You know what I mean? The jump type and stuff based on the instruction.
Well, we're getting to that. I'm still not done.
Okay.
This is already, we can do these things because these are types, so we can just trivially extract them.
That's
because
awesome.
If they are
yeah.
the same, they're literally the exact same type. Okay, but we can do more because this is still repetitive. So we can do some templating on the instruction because you see the A and C are the same, except for these 2. So we can make that a template as well. Now we have a compare plus con branch template that takes I is just an abbreviation for instruction kind in this case, like the general instruction kind. I don't want to write instruction kind every time. But it takes just an instruction kind and an x86 jump type and emits this thing for these 2. And the same is, this one is analogous. This is just D with 2 registers. And this is, I put this in a patterns struct because you can't just have multiple of these. You have to put them in something.
Right.
And now we can just write this like so. And that is the exact same as all of this.
Very nice. Okay.
And if you wanted to add like greater, it would be very simple now. So that is something you can do with templates.
I mean, I'd say that's probably the way to go about it. It's at least equivalent to the last way we did it.
Yes. And that would make declaring them very
That's
simple.
Cool.
The more complicated part is now, how do you iterate over this? So you have to do some template parameter list matching, but I'll probably do that because that's a bit complicated. It's not that bad, but you kind of have to know how to do it because you can't just write a for loop and loop over these, for instance.
Right.
That's It's not going to work. You have to use fold expressions and stuff like that. And recursion.
That makes sense. The recursion part sucks, but it makes sense. You basically have to write a visitor.
Yeah, it is basically an S expression if you look at it, so...
Yeah. That's very cool. Okay. That seems like the way to go about things.
Yeah, and then at the end we'd have some, like... whatever, and that's just an instruction, an ICEL table type that has all of these patterns. And then you just pass this in, do instruction selection based on that.
Yeah, yeah.
And one benefit of this is that this doesn't really, that all of this processing basically happens at compile time. So at compile time, it's generating the matching algorithm, sort of. So all of this is hard coded into the code, literally. Then.
Yeah. We lose the ability for runtime instruction selection, but I don't think anybody's actually doing that.
Yeah, but if you're modifying instructions, if you need to modify instruction selection on runtime, then honestly, I don't think you'll ever have to, because architectures typically don't change at runtime.
Yeah, that's a good point. It's a very good point. They're talking about there is no subscribe. There's no button. There's a big donate button. You should click that one. That way you don't give Daddy Bezos any money, but you still support the creators you like. And only support the creators you like.
Since your instruction table is basically just going to end up being a type, if you want to add a new one, you don't even need to recompile the library. You can probably just add an API for use this instruction selection table.
That's true, yeah.
Something like that.
That's awesome.
We'll see.
Local says, wish I could join the stream right now. Damn. You are at least part of it.
This is just an idea that I had, because it's pretty close to what I'm doing in my command and option library.
It's very cool. Like, this is pretty incredible.
You can take a look at that one real quick if you want to see what the code actually uses it looks like, more or less.
Oh no.
At the end of the day, where is this thing? So the big one is this one. No, that's just more small stuff.
Yeah,
it just takes a list of options and then you have to loop over it in various ways. Where's like a straightforward example anywhere? Maybe we generate the help message. Where do we generate the help message? Let's see.
So
I haven't looked at this code in a while. Where is the help message? Is it a help message? I have a macro for this, but we can just also use a regular. There we go. This is like the general way you're going to be doing this. You define a lambda that takes a template parameter, and then you have to use this abomination. We can hide that behind a function. That's not a problem. This is basically how you can pass a param, because the way lambdas work is they're just classes that overload the call operator. And in order to be able to pass template parameters to them, you have to call the call operator with its full name, which is like this.
That's so messy.
It is pretty horrid. Yeah, if in case you don't know, this is a probably do this in like a file, something like that. Basically, in case you don't know, if I have some lambda does something, whatever, if you calling the lambda like this is equivalent to writing. That's what you are actually doing.
Oh god.
Just invoking this function.
The operator call, yeah.
Yeah, and if you want to pass template parameters to it, then where did it go? I didn't actually have it open, so I jumped back out. Yeah, if you want to pass template parameters to it, as you can see here, template parameters go after the function name, and then you have to tell it that it is a template, so you have to write this. That's a syntactic mishap, because otherwise it doesn't know this is an angle bracket and not a less than sign.
Naturally.
So this is what, and then we take this entire thing, and if opt is a pack, we can fold over it with a fold expression. and that's all that this is. So that's like a way to iterate over all members of a pack if you want a more complicated thing than just a single expression.
Very cool.
Otherwise, you'd have to put the lambda in here, and that's kind of and immediately invoke it, and that's kind of horrible.
That is.
So yeah, that's the main problem, is that there is no nice syntax for this. I do hope we eventually get for loops or a variant of for loops that can do this, but currently we're stuck with this.
Not too shabby.
This is it's less a loop than it is basically just it instantiates it for each element. So this isn't really a loop, it's a loop at compile time that loops over the pack and just stamps out the calls and the templates.
That makes sense. Yep. It's basically just generating the code here.
Yeah.
That's
and
cool.
You can see there's more down here, and so on.
Cool.
And so on. So yeah, that's the main way you would loop over a parameter pack, because there's going to be a bunch of packs in here. As you can see, like multiple instructions, multiple outputs, multiple patterns, multiple operands to each instruction. It's all just going to be packs. If you look at like the stubs I've defined up here, it's pretty much all just well, actually, yeah, it's all just packs.
So there's going to be some doing there.
Yeah.
Okay. I mean,
yeah, this now all needs to be implemented, and we need a what we also need is like a machine instruction struct, like an API for that, so that this can use those.
that's what we're working on. So I think
that's it. I think. Any questions to this?
I don't think so. I think you explained it really well. It's actually very clear, at least for coming from Lisp. It's like, yeah, we have. It's basically the old iCell we had. If we still have that somewhere. Let me get to it.
Because someone's asking what standard we're using. Well, the answer is the latest, so currently it should be set to 23. It should be set to... Well, the latest is actually gonna... Well, technically we could start setting it to 26, honestly, because that's starting to be a thing now. But I don't think there's much compiler support for C++26 features currently.
Yeah, pretty much.
I think there's a few, but only in like Clang 18 or something. And other than trivial things like removing undefined behavior from lexing, which GCC has never had in the first place, so that's already obviously quote unquote already implemented. But yeah, looks like Clang 17 and 18 will start supporting some features. For instance, Clang 17 supports the user-generated static assert messages that I mentioned earlier. So we might be able to start using those at least behind a compiler flag. Or an if-def, you know what I mean.
That makes sense. That's really cool. I think that's the direction to go for iCell. You did great on that.
Yeah, I think this might just work because I'm using the same for my command line options library, so I'm familiar with this sort of programming. And this requires at least C++20, at least if you want strings.
I see. That's not too bad.
And because someone mentioned some new syntax, yeah, this, an explicit template argument list for lambdas, is a C++20 thing.
Which is 3 years old, to be fair.
Yeah.
Like, it should be speaking by now.
Already having meetings about 26, so 23 is done now.
Hey, it's 420.
Already mostly implemented by... Like, the main thing that's missing from C++20 support is modules, really. And that's pretty much the only thing, I think.
We're nearly there.
Like, it's a huge and complicated thing. Everything else, I think, is pretty much fully implemented already.
So I have a question.
Yep.
For our machine instructions, we want its operand, like its opcode. Not everyone is... Okay, I have another question now.
Oh, wait. Should I still... No, I can't talk. Should I still be sharing my screen, or should I...
We can switch
resume
back.
moving it? Okay, I'm gonna stop sharing my screen then. I almost clicked the disconnect button again. I swear to God, it's...
Perfect. We did it. I don't know. Okay. There we go. Okay, that's what I was trying to do. Okay, so I have a question. This is like my mock-up. Do I need a thing here? Why is it yelling at me? Doesn't matter.
You don't need a semicolon there. And also, yeah, the const for goes there, yeah.
So, for a machine value, is this how we should do it? And then we should have, like, should we do the same RTTI thing that we have?
So... This one is interesting because...
We're going to have operands, too. Like, do we want operand here?
This is, we're not going to have that many of them. Like, what are we going to have? Registers? Immediate values? Like, late compiled time constants, like function names and block addresses? And yeah, hardware registers, hard-coded ones, and other instructions, I suppose. And that's pretty much it.
So we're going to have registers. Let's check at the iCell file. We have immediates, we have registers.
We have immediate, well, actually, yeah, we can use virtual and hardware registers we can use the same thing for that. Yeah. And so that's just that. Immediate register, block, and like a static variable or like some name.
Yeah, static, local.
Variable, function, whatever.
And then function.
And a local variable, perhaps, that's not a bad idea, yeah.
Here, I think they're all up here. These?
Yeah, I suppose that makes sense.
Could we have, like, function and local and static ref? These could all be represented by, like, name, but this just makes it much easier to...
It's a bit different, because the thing is, function and static, yes, local, no. Because local, function and statics are just, well, names and accessed via names in assembly, but the locals are accessed via, like, the base pointer, so that's different.
That makes sense, yeah.
You can have local and name.
We'll just do...
Also, someone is asking, C++ funny modules like Fortran modules. I'm not sure I know enough about Fortran from what little I've programmed in it to answer that properly. But let's just say sort of. It's more complicated because C++ is, I would argue, more complicated than Fortran, even though Fortran can be a lot more confusing. But yeah, what I do know is that they're using part of like the same mechanisms that are used for Fortran modules. Like CMake supports Fortran modules, and because of that, they already have some idea of how to provide tooling for C++20 modules. The things with CMake, I believe what they do is they literally just pass Fortran, and that's not possible with C++. So for C++, the compilers have to like be able to dump the dependency graph and all of that. Because there's no way that anyone's passing C++ unless they have a fully functioning compiler. Because you just can't. It's not.
So we have all our kinds. We have a constructor. We don't need class of on this one, because we should never have a value. We should have one of these. These are all values.
So for these, we could also either do inheritance hierarchy or for.
Should we do like inherit from the IR kind?
Because that
like that seems wrong.
enums cannot inherit.
Well, that
from each other.
sucks.
Yeah, it does sometimes. So for these, I'm contemplating also just making it a variant because it's not like, because the annoying part of a variant is whenever you have to like really access members of all the individual things. But we never really need to do that with operands until we like at some stage later on, where we do that all at once and then it's done. Basically, so like when the assembly printer emits an operand, it needs to know what it does, and I think that's pretty much the only point where we need to like know what it is. So I think we can just make it a variant probably.
Do we have to?
We
Like,
don't have to, but I don't see it causing a problem off the top of my head. We can change it later. It's like 4 or 5 things, and we
so
typically instruction selection typically doesn't care what an operand is. It cares to know which kind it is, but that's all it needs to know. It never needs to access like the value of an idiot. At least most of the time, not.
I mean, it does for like I0. It needs to access like the whole, like the 0. You know what I mean? Am I crazy? We're also gonna need
Sometimes it does, but I don't see it being a problem most of the time. Also, why?
We're gonna need this, aren't we?
Hold on.
What's up?
Why do we have all the instruction kinds here too?
Because we're gonna need them.
Not in the value, just in a machine instruction.
Yeah, isn't that the same thing? It's gonna do the inheritance thing, the RTTI. Did we decide not to do that?
Well, we're going to...
Because aren't we gonna have like class machine instruction, which is an M value?
Yeah,
so the kinds are all going to be the same.
That makes sense, and then these. But I don't think these should be in the same enum. That doesn't make sense, I think.
Why not?
Okay, because the machine instruction can have a lot more value than just these, and these aren't relevant for RTTI, at least very much not these, because all of these are just going to be machine instruction.
So all of the... I'm confused what you're saying. All of these are machine instructions, so why shouldn't they go here?
Yes, but we're not going to have a separate machine instruction type for each of them. We're only going to have one for all of them.
Why?
Well, there's no point in having a machine, a locker, or a machine add. That kind of defeats the point of having machine instructions.
Does it? I mean, isn't this the whole like register virtual register thing? These are like the IR instructions that we start with. Because how else are we gonna... You're saying we just represent every IR instruction? So like when we first convert, if you can imagine. I know this isn't how it works. We don't make a list.
Compiler where every IR instruction just gets mapped to the same machine instruction class.
That's not what we did.
Well, there's one machine instruction type that has operands, and that's it.
We're gonna go look at the old one. We have to now. Where would it be in code gen? We're taking a look. So as you can see, all shared and IR and MIR instruction types are in the MIR opcode common. And then the architecture starts above that at 420, and each architecture will define its own.
They're not in the same enum as all the operand types.
Where are all the operand types? These are operand kinds. So you're saying each operand... I thought we were going to just have it all be one thing. Like an M value could be an operand, which is one of these things.
Okay, so basically...
You're saying just do this.
I see we need 4 things for the entire machine IR. We need a function, we need a block, those are self-explanatory, and then to model the IR we need an instruction and we need a value. Instructions are inserted in blocks, and values, well, can represent things like immediates or even individual registers. And we can make instruction inherit from value, I believe, if that makes sense. or we can just make it a. Yeah, I haven't thought about this too much because I haven't written any code with it.
Fair.
But the main thing I'm saying is that I don't see this being too like this shouldn't be complicated at all. You just need a simple thing that encodes the operands, and that's pretty much it. You don't need anything more than that because all the complexity is in instruction selection. This doesn't need to do much. Like a machine instruction is just a glorified container, and the same thing for machine value.
So you're saying, I thought we went in the old one. I tried to do it where we were like converting IR to MIR, and you're like, no. We need to convert MIR to MIR and convert IR to MIR separately in like a very basic lowering phase.
Yeah, IR to MIR is very simple, basically just 1-to-1 more or less.
Right, so that's what these are here for the 1-to-1. Right? Am I crazy? Where would these go otherwise?
Yeah. Okay, there's a difference between we have a machine instruction class and the machine instruction has an opcode, or we have 20 different C++ instruction classes. You're conflating the inheritance hierarchy with opcodes here. Because this it doesn't make sense, because a value is not even remotely the same thing as an like an integer is not even remotely the same thing as an add instruction. Add, subtract, all of these are instructions, but an integer is not an instruction, so it's not even in this. It doesn't belong in the same enum as all the instruction.
Isn't this my argument I made? Like, why are values in the same enum?
I have no idea what argument you're making.
Because integers, well, I'm saying with the IR, I'm just modeling it the same exact way, and you're like, that's crazy, which is exactly what I said when you showed me the IR. I was like, why are values inside of it? And that's what you're asking me right now.
It doesn't make sense to model the IR after the MIR after the IR, because what we have in the IR is every single one of these kinds here is a separate instruction, a separate type in C++. The same is not true for the machine IR. We won't have a separate add instruction class in C++ for the machine IR.
Now you're making sense. So why? Okay, but why does kind? So you're saying we should just have like kind just be instruction and blah 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 like this?
Or yes, that.
Okay, and then here's the thing. I was asking, where does this go? You're saying this goes in a separate enum, but you're not saying that actually the enum called kind is a different enum than that one. That one is going to go in the instruction. I didn't hear it. It's my fault.
Yeah,
I should have heard it. But if you did say it, I apologize. And this is going to be instruction like this. Is this the idea?
Sort of, yes.
Okay. And then we're going to have like arch start or something like that, right?
Something like that, yeah.
Equal OX420. And then basically every architecture will define their own enum starting at 420. So you're saying this shouldn't do this? Because there's no reason to now.
We need to think about this a bit more. I'm not sure it needs to do this, because the thing about there's a big difference between the IR and the machine IR. In the IR, we want to be able to like access all the properties of certain instructions in like a fairly easy manner. Like we have an add instruction, we need easy access to the left-hand side, right-hand side, whatever. In the machine instruction, we don't really care about accessing individual operands. It's all just going to be automated, basically. We'll never have to go, if I have a machine instruction of type 136, I need the fourth operand and this other thing. No, we're never going to be writing code that does that explicitly. So we don't need that fine-grained control over it. We can just throw it all in a bucket and leave it be. Then
we are going to be writing that code in the backend. That's literally the backend code. Is like access the second operand.
The backend code is not gonna. it's not gonna constantly all over the place be like, oh, switch on the instruction type, do that. No, it's just gonna be like, emit this thing, and then in one place in the assembly printer it's gonna see what is this thing actually. Okay, it's that thing, so I need to print that. But the register allocator doesn't care most of the time if something is an add or a sub instruction, or at least it shouldn't.
Well, it does have to. It doesn't have to look at its operands, but it does have to know if something like returns value or stuff like that.
Yeah, but that can just be encoded in an opaque manner without having to look at the instruction kind for everything.
My point is, like, what we're literally doing in the old target is like we loop over the MIR blocks, functions, blocks, and instructions, right? And then for each, we switch on the instruction opcode.
Yes, and you can see how much code repetition there is in here.
So what's the alternative?
Well,
how do you not loop over something? And what does automate mean? We have to loop over it, and we have to emit specific code for each one that's different. What are you talking about?
Yeah, but we'll find a way to encode it in a more declarative manner than this.
So you're saying, like, just make it more static? Or have, like, the code be generated? Or have it be
basically,
based
instead
on
of
data?
saying, oh, if we have an add instruction, then do this for all the operands, and then do that, and emit these bytes. Instead of just saying, we just provide the basically instruction and code, like, so declare add instruction has this opcode, and then whatever code emits an instruction just looks it up automatically and does that. Basically the same thing as in as instruction selection. So we shouldn't have to write any of this manually. Like, you shouldn't have to write MIR get op manually to emit an instruction. It should just be able to provide these are the bytes that are the opcode for this instruction. Now emit that thing.
What? So how are we going to match on the patterns of the operands?
I haven't implemented it yet. I don't know yet. I can't tell you ahead of time how everything is going to work.
That's fair. I'm just worried it's not going to work because it sounds really complicated.
It's going to work somehow.
How do you know if you don't know how it's going to work?
Work, we'll try something else. That's all there is to it.
Something else maybe being switching over everything and emitting stuff. Because it works.
But all I can see is I look at this code and I have no idea what's going on. I mean, I know what's going on.
That's a you problem.
It's a bit horrid. Just saying.
It's not. It's pretty simple. I mean, it's not that bad.
A 130 character line, I think, or something like that.
That's not a big deal.
145.
It's not, like, hard to read.
We have to read it.
What? It's
Really, you should be able to more or less tell what the code does without reading all of it. Anyway,
you can. There's a comment describing exactly what it's doing.
Yeah, when I look at the backend, it just looks to me like
that's a you problem.
A lot of code duplication going on.
It's seriously a you problem because there's really not. Like, what about any of this is duplicated? MIR get op?
Well, there's one example. How about the lines 955 to lines 973? All these else if blocks all look pretty similar.
Well, guess what? I've asked you about this many times, how to deal with zero-sized registers, auto-sized registers, and instruction selection, and you said, yeah, just keep making it 0. We'll figure out something. And we haven't figured anything out, so that's why these are here.
Oh, we're going to figure it out now. Well, not now, but when we get to it.
I don't know about that. I'm pretty sure we're still just going to have zero-sized registers. It's not like there's not a magical fix to everything to just make it better.
Size to the registers.
Huh? What'd you say?
You just need to always encode a size if not having a size is a problem.
Yeah, and the size is 0 sometimes because we don't know what it's supposed to be.
Well, it should never. That's an error. Then it should never be 0.
Well, I didn't. You helped with the IR gen and the instruction selection on the old one. This was the solution. If you have a new one, let's do it. Until then, that's going to be it, because it works. And the C++ is a rewrite. We're just doing this And we just need a backend. It doesn't have to be a fancy ultra okay to Serade backend. It can just be a backend, like one we've done before.
You got a nice backend.
Oh dear. That's a terrible microphone. What happened, local?
Yeah, good God.
I can't understand you.
This is not a microphone. You ripped out an antenna from somewhere and I don't know what you did to it, but this is not a microphone.
This is a mess.
It's like a wire speaker.
It's for all on my laptop.
I can't even understand a single thing you're saying. I'm sorry, local.
I don't know what he's saying either. I've turned him down. Everybody, this is local. We can't understand him right now, but hopefully soon we will. Okay, so we have a machine instruction. It's going to have a bunch of operands, right? Like one of these of operands.
You should probably find a more efficient way of encoding them, but yes.
It doesn't really matter.
Well, it is pretty horrible to have a vector for 3 elements 100 times.
Is it? Why? I mean, we can do like small string optimization for this.
That's what I mean by we're going to have to find a more efficient way of encoding this.
Okay. Do SSO basically. Good to do. Okay, one sec. I'm back and it's fantastic. What are we doing? We have operands. We'll do the thing soon, which means instead of doing push back all over the place, we should probably have like add operand and have this be private. Okay, we're just gonna have to do private. Everything is private in a class by default. It's public.
Yes, a class is default private, a struct is default public.
Okay, fantastic. Do we need a reference here? Does that make things better?
Probably be a value type, I think. Probably, yeah. Yeah.
And then we'll do...
It could be a value type. Allocating all operands on the heap would be quite horrible, I think.
It wouldn't be great, but it wouldn't be the end of the world. Where are we at? We have to include vector.
We should probably just include utils. That includes vector and most other things.
Is it this one? Is it this one?
It should be that one, I believe.
Fantastic.
You don't have to include vector manually.
We don't have to, but we're using it. We'll leave it. Why is this mad?
It's not in the right namespace, that's why.
Classic, classic, classic. I have to go in like 30 minutes.
Let's see.
LCC, operand, get operand. Fantastic.
You just put it in anonymous namespace, I think.
Classic. Okay, there we go. We do it. We did it. We're having done it. Okay. Where are we at? So we have operands that can be things, which can be like an instruction reference, a function reference, or a block. That's kind of in a weird order, so I'm just going to fix that. Function, block, or an instruction, and then it can also be one of these actual values. It's also going to have to like store that value, isn't it? So we're going to have like a...
Well, that yes.
Register.
I can't make register a variable name.
Immediate.
Of course, you still need the register keyword, which is, by the way, obsolete in C++. It's just a reserved word that does nothing now.
I don't know how we're going to reference a local. That's probably just going to be a value pointer.
Well, if you're just writing it out like that, then I would just make that a variant.
Possibly. How else would you do it?
I wouldn't do it any other way. I would make it a variant.
If it sucks, I'm blaming you. I don't know how to make it a variant. Do I do using?
No.
Why not?
Okay, no. I put a variant in the machine operand, not just make it a variant.
Well, okay.
Actually, you can probably just make it a variant. That might also work.
Well, okay. How does variant work? I don't know what to
Pass
give
in
to
all
it.
the types. That's it.
Just types.
Just types.
That's
no
kind of
names.
confusing.
You can only have one copy of each type.
Well, we have a local and a static, and they're both going
We
to
do
probably
have
be a
local
value
static.
pointer.
We should probably. This is something that we were doing before in the old compiler, and it kind of feels like a scuffed thing to do if you're
Please
referring
do.
back to IR structs in the machine IR. It just seems weird.
I just don't know how else are you going to do it. You literally have to do it when implementing the MIR. Because you have to map virtual registers to the MIR. Because the RA has to work on the MIR, which means you have to have all the virtual registers available.
Mm-hmm.
Should we do like this? Is this going to work?
That works. As long as the type is different, it works.
It's not working, but it's just going to be global variable. That's what we called it.
Well, are you... Yeah, global variable, I think it is.
We have to include the thing.
Mm-hmm.
I hate including. I always forget to do it. So fuck off, Operand. Eat shit.
There we go, that works probably.
So we have a bunch of operand. How do I make a variant of a specific one?
How do you just construct one?
Okay.
The type.
So I should do like to name them.
What?
All the types.
Oh, yeah,
Otherwise
that-
it's going to be a mess.
Yes, I was gonna say U64 versus usize sounds like a bit of a pain.
It really does. So we're going to do like a bunch of these.
You can always, if you need an extra type, you can make a small wrapper type. I can't talk. Oh my god, small wrapper type that contains only U64 or something like that.
That's true. Okay, so I screwed myself up. What is this first one meant to be?
I didn't know you wrote it down.
I don't remember. I deleted operand already. Come on. Okay, it's register. It's register.
Probably register.
And then we have, it's not going to be function because we probably already have that in instruction as a value.
Oh, it's probably not a function, yes.
How are we going to deal with this?
Immediate. This is probably immediate.
Nice. How a function isn't an instruction.
No, a function is a function.
So do we not need these? They're just here for numbering purposes?
Yeah, we don't need these.
Okay, they're just here for numbering purposes.
No, we don't. We should probably just remove them.
We
Because
should?
It doesn't make sense for them to be here.
Okay.
They should just be gone. A few more of these should also be like phi should also get yeeted.
That's, yeah,
Because
not a
phi
hardware
in
instruction.
machine AI is not exactly well formed.
There might be an intrinsic or two.
Intrinsics, yeah, like debug trap is the classic example, I think.
Okay, now something I know how to do. List things. Ooh, I've closed the thing. Okay. Look at this. This line is 98 characters long.
Or you can wrap it if you want to.
I mean, there's like no beat. Could you give me like beatboxing?
What?
You told me to wrap it. There's got to be at least some beat.
Oh, God.
I like that cringe. That's what I live for. Really? Okay, where are we at? So we have a way to add operands and get an operand. We don't really add, I guess we have a way to make operands. I don't really know how that works, but
You just create the operand.
we don't have a way to make an instruction.
That is a point. Well, it would have a default constructor currently. Now it has an user-provided default constructor that also works.
I think that's fine. What will it want? Operands and an instruction?
Yeah. Instruction, kind, and operands.
Yeah, that's perfect. What do we do now? Couldn't we could probably, is that how this works?
You need to give it a return type, but yes. The way this works is the operator keyword followed by an operator token is just a function name. You can use that wherever you could use a function name.
Like that?
Something like that, yeah.
We're C++ing. If this returns a const, I guess it doesn't even need to. It can just be const. Because
Oh, now it's gonna your
it's a value
operator
type.
overload is gonna complain if you do that.
Do we need to do that? Why is it gonna complain?
No. It's gonna complain because you're calling a const member function inside of a non-const member function.
Can we do this?
That works, for instance.
Add operand is still fine. This is fine. Okay. So, let's see. Where are we at? What do we do now? We basically have to loop over the IR and create a bunch of MIR, right? Of these.
Mm-hmm. Yes. Well, we need to remove phi's and all of that before that.
Yeah, I was gonna say.
Function that needs to be implemented.
Yeah, so we need to start working on that. That's next, is lowering for x86-64 to begin with.
Oh, I forgot about something. We were going to talk about tests.
Oh yeah, tests don't work yet. How can we make that work?
Yeah, it's less about the test runner, but rather about a way to be able to test that whatever code we are writing generates the right IR. And I was gonna suggest either using or writing something like a clone of LVM FileCheck.
I don't know what that is.
Yes, I thought as much, so I was gonna say something about that. Let's see. Let's see. Is there a good example on this page? Whatever. Yeah. I mean, you can take a look at the docs, for instance. Oh, this is the wrong. I have too many windows open. Where? Okay. The problem is now it's a browser window, so I need to find it. Yeah.
Is the thing happening? Can I see a thing?
What? No, I'm currently not sure. I was just gonna share a link. I can try my
Perfect.
you, I suppose.
No,
Share a link.
the link's good. The link's good. I didn't know.
I can also put it in the chat if you'd like, but that also works.
Local said I'm in the voice text, but we couldn't understand him. That's right. Sadness.
This is literally just the docs for FileCheck, and you need to scroll down a bit to see like an example.
Oh.
Okay, one sec. I'll be right back. Someone's at my.
Coolio. So FileCheck appears, it reads two files, one from input and one specified on the command line. So you like pipe something into LLVM FileCheck, flexible pattern matching file verifier. Yeah. So basically, you pipe something into grep and then also tell it a file. Match file name file specifies the file that contains the patterns to match. So you basically run FileCheck and just pipe different things into it, and it'll check whatever you pipe into it. Unless you use input file, of course. I'm sure you can use 2 files. But that's interesting. So I'm curious what the actual that's FileCheck here. So LLVM as gets IR, which is being, yeah, so it's redirecting whatever the input is of the test. That run there, okay.
It's on definite, there we go. What I was saying is you basically just put comments in the file and then it checks that it generates that, more or less.
Interesting.
And
So
you can also use regular expressions to match like names of temporaries and stuff like that.
so I don't know what's happening, to be honest. What is this?
I can show you and I can demonstrate it if you'd like.
Possibly. So I have a question.
Mm-hmm.
This file, it says it takes in 2 files, one to match a pattern and another to actually check.
Yes.
How does that
So
work if it's comments?
If you look at this run there, what this will do is it. Can you stop scrolling maybe, and then I can explain it. If you look at this like run comment there at the top.
Yeah.
It runs LVM as, which is the LVM assembler. We'll pipe that into LLC, and then we'll pipe that into FileCheck. Then also pass this file. That's what %s stands for, to FileCheck. So we'll accept
%s is this file.
Sorry, yeah, %s is the file that you're passing. So this is also assuming that it's working with LVM's test runner, which will then pass this run directive and run it, substitute the file for s. There's 2 parts. FileCheck just handles the comms. The run directive is a separate tool. That's more like our test runner. FileCheck is just for pattern matching, basically.
So the IR, okay. So they call it 2 files, and then they use the same file for both of them.
Well, no, it's the one quote-unquote file is the output of the compiler that it just writes to stand it out.
Right. Well, I'm just, from the beginning, FileCheck reads 2 files.
Mm-hmm.
And
fundamentally, that's what it is.
Yeah,
that's why.
It's just very confusing to realize the 2 files are right here.
Yeah, it's in Unix. It's all just a file.
Just, I mean, having like this file is both the files that get passed to FileCheck instead of having the requirement of the knowledge of the LLVM test runner replacing %s with the file name, and that's what this is. Like I don't know. I thought %s was this, the contents of this.
Yeah, no, it's the file name.
Yeah, that makes more sense. Okay.
I can
So
show you a few examples of this if you want to see.
It basically just ensures that it creates certain machine code. Is that what this is?
Strings are present in the output, basically.
Okay. That's confusing more. Local's back. I'm going to turn him back up. Hello, local.
Hello. Yeah, I can give you an example
Hey,
then,
I can hear you now.
if you want to see one.
Yeah, let's do it.
My microphone is dog ass, and I need to go get tech support on that or something.
Okay, local, you're way too quiet now. I have to turn.
It sounds like a you problem.
No, it's not a me problem. I have you turned up to 100%. It's a you problem.
I don't have control over it at the moment.
Good God.
Discord gives you 200% for a reason.
Yes, but the problem is if I share my screen in the app, it doesn't want to. It doesn't let me do that. It just crashes. So I am in the browser currently.
This is a headset I've never used with this laptop before, so I just don't know what to do without it.
I see. We just need to listen very carefully, I suppose. Anyway, Lens, do you want me to show you some examples or?
Show me deeply, and then we'll wrap the stream up on that.
I can share my
Nice.
screen again if you'd like. Where is the thing? This is the thing. I need to stop watching. There you go. That's why I always click disconnect, because the stop watching button is where the disconnect button is. Naturally.
It is.
Let me know if you can see this.
Nope. It's loading
It
forever.
says it's still loading.
Yeah. We'll see. I believe. So basically, what does the check mean? Like, so check just tells it to run FileCheck?
There we go.
Did it work?
Can you see it now?
I cannot. Maybe in a... I've got...
Fine, we're going to try again.
Okay.
Stop sharing.
We got
Go
this.
here. Again, good. There we go.
Hey!
Discord is so...
Mm-hmm.
Okay, can you see this now?
Mm-hmm.
Yeah.
Let me find an example that's less. By the way, before you say this is unreadable, the reason why this is unreadable is because I'm using MLIR. It sometimes just ends up looking like this. Yeah, this is one instruction. So before you say that the file check patterns are unreadable, the II is unreadable. That's why. Anyway, like there's a simple example. Something you can bind it. This is how you finish. So check basically means check that this string is in the output, because this thing will lower to this MLIR instruction, something that starts with it, and then check that on the next line we have this thing, which means I suppose what I can actually show what it generates, so we can put those side by side. What is this? This is awkward, it would seem. Here we can see this is just running the compiler on this file. That's also what the run directive does, and it spits out the IR. We can see we have this line here, func private. This function, that's the start of them. I'm not going to write out the entire thing, it's too long. But yeah, and here we can see we have 0 is a local variable instruction, and that's here. This is just binding the temporary to the name A. This is a regular expression here. The syntax for this is not ideal. We might want to find the shorter one for this. But
avoiding regex is probably a good idea.
Yeah, well, we need some level of regular expressions if you have automatically generated names of temporaries that you can't predict, except for that they have this general pattern.
Right.
But yeah, as you can see, this basically just checks we have a local line instruction, then on the next line we have a store instruction, and then later on, not necessarily on the next line, otherwise I would have written check next. This is check next is also a bit long. I would also look for a way of abbreviating this. I mean, it depends on whether we want to just use FileCheck or implement something like it.
I do like checks.
And then eventually, we have this other check, and this checks that there's some instruction that loads A, which is this one, and we do have that down here, loading 0. Then on the next line, we are loading it again, and then we're adding them together. That's this one, and then we're calling. I should probably check that it actually calls the right function, but yes.
Yeah.
So that's basically how this works. The check means check that this string is in the output. Then you can write things like check next, check that the next line has this, and so on. So for instance, here's another example, just a constant follow-by call.
So, are we validating that the correct... What are we validating here? Like, how does... this is IR, right? So would we write this...
IR, yeah.
Would we write this stuff within an intercept file?
Yes.
We would be writing an intercept file and then write these. These are just comments. In case the colors confuse you, I have no idea what C line is doing here. This is not syntax highlighting I wrote. It just decides to highlight my files this way. I have no idea why.
Okay.
If you're confused about that, so am I. But the triple flashes are comments. So we would be writing just... so for intercept, for instance, I can give an example, I suppose, by...
How does it know what maps to what?
the position of
I
the
don't necessarily
commentary.
know what maps to what. But for instance, if you wanted to check that, I don't know, what's a good example? We'd have to give B, C, and that's then just A plus, sorry, C, B plus, yeah, I'm forgetting that. B plus C. Then you just write, I think we're using double semicolon for comments now. And then you just write, if you were using FileCheck, you'd write check, okay, what is the first thing that we expect here? We expect a function definition, so that's going to be A is, and if I recall correctly, we're just literally writing it like this currently. We give the temporaries a name, so we'd have to, yeah, let's just say sum A, and then on the next line, we have, what will we have first? Okay, we probably have the local value. I'm going to skip like allocating the parameters, so we're going to skip to eventually we're going to have a local, have a look. So, okay, this is too. I don't want to type out all the IR right now because
Yeah,
I'd have to
that's
allocate
fair.
variables, save this into it, blah blah blah, whatever. Like some temp, this would be like B would be like a percent sign followed by 0 to 9 one or more times, and this would be I think we're calling it a locker.
Yep.
And this would be an I64. That would be B, basically. And then we'd store the initial parameter value into that, and so on. We could just generate that it generates this IR for this code.
So optimizations would break the test?
Well, you run it without optimizations or run it separately. That's what I'm doing here. For instance, here I have a test that I'm running with optimizations enabled explicitly to ensure that this is optimized to just a constant.
But we can't ensure that an optimized and unoptimized test are the same. If that
So
makes
you wouldn't
sense.
run every test with or without optimizations, then you'd have separate tests for the optimizer.
That makes sense.
Because what this is doing, it's generating, it's not just checking the return value, it's also generating that, checking that like the IR makes sense.
So the textual IR or like the in-memory IR? It's in-memory, right? Or just textual?
Textual IR, you can't look at them in memory. You just print
Which is why
the
it
IR
takes
and it
two
looks, it's just
files.
text comparisons.
Okay, I didn't know how much of the like API it was using, or if it linked with libLCC and like was a part of it or not. So
Sounds like
this
it's
is, I
zero.
can show you how to do this manually. I have this test. What this does, it just does this. That's what it runs, and then it says, okay, no error. If I do add an error, if I put like nonsense in here, like I forget an A here, and it will yell at me and say, again, my IR, this is MLIR, the lines get very long because of that.
and we don't.
Says expected string not found with A equal to 0. So it was expecting, like, because there is no LOD in the output, and here is the output.
Interesting.
Try to match again. Then I can put the A back, and if I run it again, no problems.
That's cool.
That's all it does. And this is the thing that interprets as run directive as a separate program.
So what if we had the like thing that interprets the run directive? They're all going to be the same run directive. Of just
pretty much, yeah.
Yeah, so we could just have that be encoded into like the test runner. So we don't need to write a run.
It will be like that. Sometimes it's a bit different. For instance, I have what was that? In here, I have 2. This is run twice. Once regularly and then one time with optimizations. And in that case, I'm checking the LVMIR to see that this nonsense is optimized away to just 42.
Lol. That's awesome. It's definitely a very involved way to test. It's not quite as, but it does test the front end very specifically.
Yeah, it tests that the IR generation is correct, and we could test like because we can print everything, so we can test the IR, we can test the LVMIR, we can also just test that it doesn't error. Like for instance, here I have here I'm testing for errors. For instance, these are not declared, so what I'm doing here is what is this? This is just semi-error. Run this with AST. Could probably also just run this with SEMA. And then this has an error, unknown symbol A. And here I'm checking that this error is there, but also that I don't get an error of unknown symbol B, because it's not supposed to just, if it finds an error in an expression, it's supposed to stop reporting errors for that expression. In this case, that's what this is checking. You can also just check it for diagnostics with this.
That's very cool. Okay. So it's very versatile.
Should actually just be that.
How complicated is the tool to write?
Implementing the tool or using the tool?
Implementing.
Implementing the tool will basically entail it's line based pretty much. So you go through the input line by line, and then you just go top to bottom. You need to pass all the check directives, potentially with regular expressions, and then just match line by line basically. Like, it doesn't try too hard to match; it just goes line by line.
Yeah, that makes sense.
So it wouldn't be too complicated, I think.
I see no reason to not do it.
Sounds fairly straightforward.
It sounds like similar to the old one. Can we test the return status? How do we do that?
We could. I'm not sure you can. I have to do something up here, probably in the run directive. I'm not sure you can do that in FileCheck, but we can add that as a feature.
Nice, yeah. That makes sense. Like asserting that whatever the run directive will be, or if that's
yeah,
built
but what
in.
you can do more or less instead, what I do something equivalent. Where is it? In here, I check that we have a tail call to exit with the value 42. Which is basically like saying this thing should return 42. And it should really return
I see,
42
yeah.
if we execute it. It does return 42, there you go.
Nice.
If we optimize it, we can see it that's what this does, LVM03. You just have 42 here. One way to check for the exit code. There should be no return, by the way, that's still not implemented. Anyway.
Yeah, I think that's a great way to
By
do
the way,
tests.
if this looks a bit like if this looks like a mess here, it's just because the II is horrid. Because it gets worse if we look at like refs is the worst one, I think, or one of the worst ones, where it's just a wall of text or a fairly simple line of code. Okay, this is a horrible. Like, the regular expression syntax really isn't the best, because look at just how many times I'm repeating this thing.
Yeah.
Like, we should have a way of specifying, hey, reuse this regular expression, please.
Yeah, I think it'll...
Like something like that.
Yeah, that's a great idea. Even if we don't use regular expressions.
Yeah, I might just look into writing something like FileCheck as a separate tool so I can use it myself.
Nice, yeah.
Because this is getting a bit long.
Yeah, that'd be sweet. Alright, well that's perfect.
Yeah, that's just an idea I had because I've been using this recently and I think that it might work for... Was it testing the IR? Because just testing the return value isn't gonna... We don't have a way of testing if optimizations actually optimize anything that way. Or if the II is even remotely correct and maybe just happens to return what it returns.
Right. Yeah, it's definitely more thorough. I don't know, I think it'll be good. It seems kind of very versatile.
Any more things you want to ask about this? Or...
I'm trying to think. So... Check next, make sure that the next line has that on it.
Yes.
So if we...
check is just on line later.
So we're going to be like printing out our IR to check the IR. I guess that's why we'd have the run directive, because we could have it check like if a string is printed out when it's run.
Yeah.
Next question, what syntax is that run directive? Like, do we have to parse a whole...
This is just a shell pipe currently, so there is a tool that passes this. It doesn't need to be too complicated. We can just we don't need to support that many things, because the two things that it has some sort of like quote unquote variables where I've specified the path to the compiler, the path to the current file. That's the only two variables you really need, and then you can just split on the pipe basically. Or in some cases you need this pipe here, which pipes standard error instead of standard out. But that's pretty much it. You can just split on that and just run these as shell commands basically.
I mean, yeah. Okay.
That's all it does really.
I don't think I have many questions. Could we like test
Also,
MIR with this?
So just one thing, if we're doing this, I'm definitely gonna make check next the default, because look at this.
Yeah. So it'll be like checked next. Like check new would be the whatever.
Yeah, well, I'd even write it shorter, like just like this maybe for check or whatever. And where we need to like it doesn't know about comments. Either we teach it what is a comment, or we just like add some character that. Yeah, I still have to think about what the best way of telling it what to check is.
We could do like a little symbol. It doesn't have to be a
some
word
symbol.
either.
But it needs to be valid. It somehow needs to be we need to put it in a comment, because the actual compiler should just skip that, obviously,
Yeah.
because it's in the same file. Like, I don't know. We could do something like this or whatever. It doesn't really. Also allow the user to specify a custom symbol or something.
Local suggested the Czech Republic and China. CK and
Something
CM.
like that,
Yeah.
for instance, yeah.
Yes, exactly that.
Literally just allow specifying that somewhere.
Yeah.
It doesn't need to be hard-coded.
That makes sense. Yeah, I think that sounds good. Oh, thank you, Coroner. I really appreciate it. I think that is it for this stream. We've decided that C++ sucks. No one should use it. No, I'm kidding. It's good. It's a good language. Yes, exactly that too. See, Local agrees. No, C++ it is pretty cool. That instruction selection stuff I'm excited for.
Just, I will say I've stuff to do right now for uni. Also, I work there also part time at least, so I won't have that much time to implement all of that immediately. It might take some time. You
Yeah,
still
that's
need
cool.
to do like lowering to anyway, so that's gonna take a bit.
Yeah, that's what I was gonna work on. Static data maps of like opcodes for x86 64. And then yeah, it's basically just lots of lowering parameter sys5 x64 calling conventions. We get to figure out how to pass an array to a function on different platforms. It's so much fun.
Yeah. The thing is, I might even do like the testing stuff first, so we have that, because
That's probably a
thing
good
is,
idea.
this is maybe just my point of view, because I've worked on too many compilers. But for me, I don't need to see code execute. Like, if I see this, I know that it works. I don't need to see it return 42, because I know that it's just going to do that anyway. That's not interesting to me. Actually execute the code. I'm fine with just seeing IR. I don't know how you feel about it.
For the tests, I don't care, but I definitely don't trust the IR. Like, oh, if the IR is right, it's right. Like, I don't know. Things can go wrong.
No, what I just mean is yeah, obviously there can be bugs in the back. What I'm saying is, if I'm implementing a new feature, at least in terms of in the front end, I don't need to see it execute. I'm fine with just seeing that the IR is correct.
I see. Yeah, I'm definitely different there. I do not trust that it works until I've seen it work.
Yeah, well, in this case, it does work.
But I think the tests are like not for me. So it's fine if they work on the IR. You know what I mean? I think that's good. This is good. And ideally, we'll stop making so many changes soon. Well, really, there's not that many more changes to make.
There's just more stuff to implement, yes.
Pretty much. We have to do some sort of generics or templates, but that's like the largest thing ahead of us.
That's a bigger one, actually. That's a bigger feature. That's just in the front end, so...
Yeah. That's language design, Mason.
One thing that's
Basically.
missing also is name mangling currently. Because we do have overloading, but not mangling. I'm pretty sure we have overload. I hope we have overloading. Oh, I can... Will it stop streaming if I switch the project? No, probably not. I'm pretty sure we have
It'd be in sim.
overloading. We
Yeah.
do have my my overload resolution algorithm. Is this one? Oh, this just checks if an overload set is correct. It doesn't have the code. Where's that's all the built-ins. Fascinating.
There it is.
Is overload set? Brilliant.
Yes, wonderful. So yeah, there's some things to do.
Yeah. But yeah, I'll just copy over the overload resolution algorithm.
Yee.
And then that's it.
That's perfect. All right. Coronar says there's a lot of hate for C++ recently, I feel. It's not just recently. I think C++ is it's just so large that it's inherently going to be hated. Like, you can't please everybody, so if a certain percentage of people do use something, then everybody's going to not be happy. If that makes sense. They're literally trying to like make all of computers work across the world. Which
well, in C++, one of the design principles is that you should be able to program the way you want to. Like when Bjarne designed C++, he explicitly didn't want to prescribe a certain style of programming. Even though, for instance, there's some people that say C++ is object-oriented, but it really isn't. You can do object-oriented programming, but you don't have to. And in fact, some things that some people might consider object-oriented, like even stuff like public and private, have nothing to do with object-oriented, but Bjarne modeled them from he got that idea from his experience in designing operating systems, where you have like access control as to who can read or write to a page in memory. That's where he got public and private from.
I'm glad I don't say everything out loud. That seems like a great place to end the stream. I hope everybody was able to watch. Everything worked out. It was a new bitrate, new resolution, new computer, new audio. It's new everything.
Is it now?
It's 1080.
Oh, it is 1080p now. Nice. It used to be 720, I think, right?
Yes, and it probably still should be because of Twitch, but it's we're gonna see how it goes. It's what OBS told me to do, so I was like, I'll trust it.
I see.
Bless Cornar, thank you so much for watching. You have a good day as well. Would you like to plug anything local or eternal?
Not particularly, I think.
Okay. If you don't know, Local is developing parts of LCC, mostly the front end for his language, Laya, or lawyer. And and it's coming along nicely. He's been trying a long time to get it working, and I really hope LCC is how that comes to fruition. No, one day you will get it right. Maybe one day. We'll see how it goes.
Yeah, this is also
Mayhaps.
This is also something I was going to mention, is that I will say that a compiler is a pretty large project. So if you're expecting this to be done, it won't be. Not anytime soon. So if you want to finish a project every once in a while, I'd suggest like maybe starting some smaller ones every once in a while. Because currently, you're in the unfortunate situation that your three main projects, at least from what I can tell, being a compiler, an operating system, and a text editor, are both very large programs. Both. Either three things, and I say both. But you get the point.
Yeah, I know what you mean. It's not ideal, but it also, I mean, I don't know. I'm not good at short-term stuff.
What I'm saying is that if it feels like it's a lot of work, that's because it is. Like this isn't
That's fair.
gonna be fun anytime soon.
That's very true. Every now and then I create a project folder and create a build setup, and then I'm like, I did something, and that helps. If the project has no goals, then it's done right away, so I complete a lot of projects. That's right, the opposite of ambitious. Anyway, that's I'll keep that in mind. And this is good. We'll do this hopefully more often. I hope I have more time. I'll try to make it. I'll try to make more time. And yeah, that's gonna be it. You should go Eternal as a Patreon. Local's working on the stuff. Check out his stuff. I'm sure he has stuff. He goes by Nashiora, which is here. I'll just do this. Spelled like this. I know my own rules. I spelled it wrong.
Spelled it wrong. Very.
I typed too fast. Don't worry about it. The second one.
Spelled it wrong.
And then this is Eternal, and
Yeah, that is pretty abysmal even for you.
I didn't. How do I?
I don't think you have that character on your keyboard.
I don't, but I can copy paste it.
Okay. Yeah, that makes you more competent than I am, significantly.
Hey. But yeah, thanks so much for watching. I'll see you next time, and go check out these people. They're awesome. Bye.